Hello and welcome to today's video on similar shapes involving area and volume. So I'm just going to start off with a little example here. I think it'll help you understand this a little bit. So here, if I have a square like so, and let's say these squares are of side length, I don't know, let's say 5, let's say 5 centimeters, 5 centimeters. Well, you know the area of this is going to be 5 times 5, which is 25 centimeters squared. Brilliant, super, fine. So what I'm going to do is I'm going to create a similar shape and I'm going to enlarge it with a scale factor of 3. So if I've got my similar shape over here, like so, and I'm going to enlarge these shapes, so it's going to be times by 3, obviously, because the scale factor is 3. So this one over here is going to be 15 by 15, which means that the area of this one is going to be 15 times 15, which is equal to 225 centimeters squared. So although I have increased the side lengths by 3, so times by 3 and times by 3, if you look at the area of this, you can see that it's clearly not 3 times bigger. In fact, if I was to divide this by this, so 225 divided by 25, this is actually 9 times bigger. Okay? And this kind of makes sense because if you think about this, you're timesing by 3 once, and you're timesing by 3 again. So you're timesing by 3 twice, which is the same as saying 3 squared. Okay, and 3 squared is 9. That's what we're doing. We're timesing by the area scale factor, which is 3 squared. Okay, so that's the first point. The fact that your area, when we're increasing the area, it's not the same scale factor, and actually we need to square it for the area. And this works exactly the same with volume. I'm not going to show you the example for volume, but it works exactly the same with volume. Now the thing that's really important is that if you've got your scale factor and you want to work it with lengths, so if you have a smaller length, let's say, and you're trying to get to your larger length, I'd probably get this down in your notes. Remember, the only way to learn maths is to do it. So if I've got a smaller length and I'm trying to get to my larger length, then I times by the scale factor. So that was like the times by the you times by 3 in the case of the one we just had. If you've got a smaller area and you're trying to find your larger area, you can't just times by the scale factor. You need to times by the scale factor squared. A little bit like you've got centimeters squared. And in the same way, if you've got a smaller volume and you want your larger volume, then with this one you need to times by your scale factor cubed. Okay, now this is the important part. I would definitely get this down in your notes because this is really important. If you understand this, a lot of it kind of will click into place. That's the key part there. So with lengths, from smaller length to larger length, we just times by the scale factor. For areas, smaller area to larger area, we times by the scale factor squared. So the one we had was 3, wasn't it, where the scale factor? And then the area scale factor was 3 squared, which was 9. And if we had the volume, you have to cube it. So it'd be 3 cubed in the one that we had. But I'm going to go through some examples of that anyway. Okay, so let's have a look at our first question. I'll make it big for you so you can have so you can see it. So here's your first question. So shape A and B are mathematically similar and the length of A is 3. The length of shape B is 9 centimeters. If the area of A is 8 centimeters squared, what is the area of shape B? Okay, so let's get this one down as example 1. Now the first thing we need to think about is always finding that scale factor. This is the bit that we really want to think about. So I will draw this out. You don't have to draw them out all the time. I might not draw all of them out, but I will for this first one. So I know The width of this is 3 centimeters, and I know the width of this one, it's not the best drawing, is it? The width of this one is 9 centimeters there, okay? So when I'm working out my scale factor, it's your larger similar side divided by your smaller similar side, which in this case is 9 centimeters divided by 3 centimeters, which means that my scale factor is 3. It's 3 times bigger. Now, the difference with this one is it tells you the area of A, and the area of A, so the inside here, is 8 centimeters squared. Okay, that's what the area is. So if I want to find my larger area, I times by the scale factor, use the units to help you, the scale factor squared. So times by 3 squared, like so. So going from small to larger, I times by the scale factor squared. So in this case, it's going to be 8 times by 3 squared. Very similar to the example we had, wasn't it? So 8 times by 3 squared, which is equal to 72 centimeters squared. Absolutely brilliant. Okay, so pause now and have a little go at that one on the right hand side. Pause now and have a little go at that one on the right. Okay, so let's have a go at this one together then. So this time I've got 2 trapeziums, trapezii, I'm not sure which one it is actually. So I've got 10 centimeters there, and I've got 5 centimeters here. And now the thing that's a little bit tricky with this one is I'm going from larger to smaller, so I'm going to have to divide by that scale factor if we do the use the scale factor formula. So my scale factor is going to be your larger similar side, larger similar side divided by my smaller similar side, which in this case is 10 divided by 5, which is equal to 2. So I know that this shape is 2 times smaller going that way actually, isn't it? You know, it tells you the area of shape A is 60 centimeters squared. So what's the area of B? Now, because I'm going from larger to smaller, I'm not going to be timesing that by that scale factor. I need to divide by that scale factor. So in this case, I'm going to be dividing by the scale factor squared because it's area. Okay, sorry. Divide by that scale factor squared. So divide by 2 squared. So it's going to be 60 divided by 2 squared. 60 divided by 2 squared, which in this case is equal to 15 centimeters squared. Absolutely perfect. Nice and easy. Okay, so let's check both those answers. 72 and 15, absolutely brilliant. Okay, so let's have a look at this one now. So I'll make it big for you. So we're not looking at areas now, are we? We're looking at volume. Okay, so we've got two cylinders, haven't we? So let's have a look at this one now. Again, I'll draw them out. This is example 3. I've got a cylinder here. It's a quick drawing. There, like so. And I've got a smaller cylinder here. Like so. And this one has got a height of 20 centimeters. And this one here has got a height of 10 centimeters. So the first thing that I always do is I'm going to work out the scale factor, which is my larger similar side divided by my smaller similar side, so which is 20 divided by 10, which in this case is 2. Now it's telling us that the larger shape has a volume now, not area, a volume of 100 centimeters cubed, a volume of 100 centimeters cubed. So if I want to find out my smaller volume, I need to divide by my scale factor, but because it's volume, I need to cube that scale factor now, don't I? Okay, again, follow the units, centimeters cubed. So in this case, it's going to be 100 divided by 2 cubed, which is equal to 100 divided by 2 cubed. Again, it's cubed because it's volume, which in this case is equal to 12.5 5. Remember, I'm dividing here because I'm going from larger to smaller this time. Okay, and that's it. Centimetres cubed for my units. There we go. Okay, that's the key part to this. If you understand this, you'll start to make sense of everything else. So, pause now and have a little go at that one on the right-hand side. Pause now and have a little go at that one. Okay, so let's have a go at it together. Again, we've got two volumes, one's bigger, one's smaller, both similar shapes. Nice quick diagram there. Try and do a smaller one. It's not that great, is it? Brilliant. So we've got A, we've got B. It's telling us the length of this one is 15. So this one here is 15 centimetres and this one here is 5 centimetres. First thing, as always, is I work out the scale factor, which is my larger similar side, 15, divided by my smaller similar side, which is 5. So my scale factor is 3. So if I know my larger volume, which is 108 centimetres cubed, I work out my smaller volume by dividing my scale factor, which in this case is 3. But because it's volume, I need to divide by 3 cubed. And that's the key part of this. That's the new part. Okay, when I'm dealing with area, I'm squaring. When I'm dealing with volume, I'm cubing. Okay, so it's going to be 108 divided by 3 cubed, because it's volume. 108 divided by 3 to the power of 3, which in this case is equal to 4 centimetres cubed. So there's my volume there. Brilliant. So let's check those answers. Let's have a little look. 12.5 and 4, absolutely brilliant. Okay, so let's have a look at the next question then. Now this one here, I've just put these ones up. Both of these were GCSE questions. So maybe pause and have a go at those yourself. Both of those are GCSE questions. Okay, let's have a go at them together then. So I'll do both of them at the same time. Hopefully you've had a go at both of these. Now we've got this little monster, haven't we? And the monster has a surface area. Now think about the area. That's the amount of paper it would take to make this monster, maybe. And it has a surface area of 300. But the company wants to make a large monster with a bigger height. But it wants them to be similar. So I don't know how I'm going to draw this monster. It's not going to be very good, I'm sure. So there's my monster. There it is. It's absolutely terrible. There you go. That's not too bad. So I've got this monster, and it's saying the height of this monster is 20 centimetres there, like so. But it's saying there's going to be a larger monster. I'm going to draw another monster now. A larger monster there. But it's saying the larger monster has a height of 120 centimetres. Okay. Now it says the smaller monster has a surface area. So surface area equal to 300 centimetres squared. So the first thing I've got to do with this, same as always, is to work out what that scale factor is. So my scale factor is equal to 120 divided by, so my larger similar side, divided by my smaller similar side, which is 20. So 120 divided by 20, which is equal to 6. So this monster here is 6 times bigger. Now the problem is that I'm dealing with area, and I can't just times by 6. That's what most people will make a mistake. They'll just times it by 6. Because it's area, you need to times by the scale factor squared. Remember to follow the units, centimetres squared. So I'm timesing by 6 squared. So in this case, it's going to be 300 times by 6 squared, like so. 300 times by 6 squared, 300 times by 6 squared, which is equal to, quite a big number, 10,800 centimetres squared. Brilliant. Hopefully you got that right. If not, get this in your notes. Now I've put this next one up because it doesn't talk about centimetres cubed, it talks about litres, but litres is also a measure of volume, so don't be too worried about that. You can use the measure of volumes on this. So I've got 2 cups, or 2 vases. There's my first. This one's bigger. And here's my other one, a little bit smaller. Now it says that this one here is 30 centimetres. This one here is 20 centimetres. So the first thing I do is find the scale factor. So 30 centimetres divided by 20 centimetres. 30 divided by 20, which is 3/2 or 1.5. So I know that this vase is 1.5 times smaller. Now it's saying here that the volume of the smaller vase is 0.8 litres. Okay, now this is where my my centimetres cubes falls down a little bit, because usually this isn't centimetres cubed, it's litres, but litres is a measure of volume. Okay, so if I want to find out my larger volume, I need to times by my scale factor, which is 1.5. Because litres is a measure of volume, it needs to be 1.5 cubed. Okay, it needs to be 1.5 cubed because it's volume. So in which case this is going to be 0.8 times by 1.5 to the power of 3. Let's have a look at that. 0.8 times by 1.5 to the power of 3, which is equal to 2.7 litres. So this one here is 2.7 litres. It's all about that cubing and understanding that litres is a measure of volume. That's the extra layer here, isn't it? Okay, so let's just check those answers. 10,800, brilliant, and 2.7 litres, super. Okay, so we're going to step it up a little bit here. Okay, if you are struggling with this at the moment, I'd probably pause and have a go at some of the questions at the end before you move on to this bit, because this next bit is the trickier part. So this is like kind of your real grade 7, 8, 9 stuff coming on here. Okay, so here we have 2 mathematically similar pots, A and B. So let's draw these pots. This one here is example, which example is this now? Example 7 it is. So I've got 2 pots, smaller pot and a much bigger pot, both similar shapes, like so. This one here has a height of 8 centimetres. However, we don't know any other heights, but we do know the volume of both of them. So this one here, the volume is equal to 264 centimetres cubed. The volume of this one is 891 centimetres cubed. Now the problem here is that when I'm finding out my scale factor, I've been working out the scale factor for the lengths. If you want to work out the scale factor, you've got to work out the scale factor, because I don't know 2 lengths in this one, I've got to work out the scale factor for the volume first, and then I've got to work backwards to find the scale factor for the lengths. Now, it's worth here actually writing scale factor for area, scale factor for volume, scale factor for lengths, and then you can talk about the way that you scale things up and down. So here, because I've got 2 volumes, my similar volumes, my scale factor for the volume is equal to my larger similar volume divided by your smaller similar volume. And in this case, that's equal to 891 divided by 264. So 891 divided by 264, which in this case is equal to 27 over 8. So this is the scale factor for your volume. Now, if I was trying to find the scale factor for the volume, I would cube my scale factor, wouldn't I? Okay, if I want to find out the scale factor of the volume, I need to cube. If I want to find out my scale factor for my lengths, so working backwards, we need to do the opposite of cubing, don't we? Because I know what the scale factor of my volume is. So if I want to find out my scale factor for my lengths, I need to do the opposite. And the opposite of cubing is the cube root. Now this is where it's a little bit trickier, because here I know the scale factor for my volume. So in which case, my scale factor for my lengths is going to be 27 over 8 cube rooted, because I'm working backwards to find out my scale factor for my length, which in this case is equal to shift cube root. If you're not sure where that is, it's just above the x with a box with it. So cube 3 root of fraction 27 over 8, which in this case is equal to 3 over 2, which is equal to 1.5. So I'm working backwards now, and this is my scale factor for my lengths. Okay? So if I know this here is my smaller height, and I want to work out my larger height, I need to times by the scale factor for my lengths, which in this case is 1.5. So it's going to be 8 times by 1.5. I'm not squaring it, I'm not cubing it, because I'm dealing with lengths. So 8 times by 1.5 is equal to a height of 12. Now that is trickier, okay? That is tough. That's why I said to pause if you're not 100%. Because this is the key part here. I've worked out my scale factor for my volume, okay? So then to work out the scale factor for my lengths, I need to do the opposite of cubing, which is going to be cube rooting. Okay? Then I've got my scale factor for my lengths. And once I've got that, I can use this to work out the height of my other bowl. Tricky that, very tricky. Now I've got 4 more questions on this, all very similar, okay? But they are tricky, okay? So if you do want to take some time to look over that, so let's just check that answer. 12, brilliant. Okay, so here's our next one. This is example 8 now. If you want to have a go yourself, have a go yourself. I'll make it big for you. I will go through it in a second. Okay, let's have a look at it together then. So I've got 2 prisms, like so. There's one. There is another one. This one's smaller, but they are similar. And it tells you that the surface area of A is equal to 48 centimeters squared, and it tells you the surface area of this one is equal to 12 centimeters squared. And we're trying to find the volume. Let's put the volume above it. So the volume of the A is 80 centimeters cubed. Okay, so it's a bigger volume. So the first thing we need to do, same as always, is work out that scale factor. And the problem here is I do not have any heights, and I don't have a similar length. Okay, I don't have a similar height, don't have a similar width. So the only thing I can work out is the scale factor for the surface area. And my scale factor for the surface area is going to be my largest similar area divided by my smallest similar area, which is 48 divided by 12. 48 divided by 12, which is equal to 4. So remember, this is the scale factor for your surface area. If I want my scale factor for lengths, and I have my area, well, if I was going from lengths to area, I square it, don't I? So to work backwards, I need to do the opposite of that, which is square rooting it. So to find out my scale factor for my lengths, I'm going to use the square root, which is the opposite, and I'm going to use the square root. And the square root of 4 is 2, which means these lengths are 2 times bigger. Now I've still not finished there, because I don't know the lengths, I know the volume. But you've always got to work out the scale factor for the lengths first. Okay, so I know that the volume of this one here is equal to 80 centimeters cubed. Okay, and I know the scale factor for my lengths is 2. So if I'm trying to work out my smaller volume, take note it's smaller volume, then I need to divide by my scale factor, which in this case is 2, but because it's volume, I need to cube that. Okay, divide by your scale factor for your lengths, cubed for volume. So in this case, it's going to be 80 divided by 2 cubed, 80 divided by 2 to the power of 3, which in this case is 10 centimeters cubed. Okay, so we've worked out the scale factor for the lengths, and to work out the volume, I divide by the scale factor cubed. Okay, it is tricky that. So these usually come up towards the end of the higher paper. There's a lot going on here, so they are tricky, so do take your time with them. So pause now and have a little go at that question on the right hand side. Pause now and have a little go at that one on the right. Okay, let's have a go at it together then. I'm going to be able to draw this now. So here we've got our shape, and we've got a smaller one on the left, which is there like so. Absolutely rubbish that is. Hopefully you can draw some better than me. There we go, that's fine, that's not too bad. And I've got a bigger one here. I'm not going to draw the ending. And this one's A and this one's B. So now we know that the area of A is, the surface area, let's make sure we say surface area. Surface area of this one here is 10 centimeters squared. The surface area of this one here is 40 centimeters squared as well. And I know the volume of A, so the volume is equal to 20 centimeters cubed, and I'm trying to find the volume of B. Now, I don't have any lengths involved, so the only thing I can work out is the scale factor for the surface area, which I know is my larger surface area, which is 40, divided by my smaller surface area, which is 10, which gives me 4. Now, it's usually the case that these are, if it's area, they're usually square numbers. Not always, but sometimes they're usually square numbers. If it's volume and you're working out the surface area for the volume, the scale factor for the volume, it's usually cube numbers. That's usually a little hint. So I've just worked out the scale factor for the surface area. So if I want the scale factor for the lengths, instead of squaring, I'm going to do the opposite of that, which is the square root. And the square root of 4 is 2. Okay, so now I've just worked out the scale factor for the lengths, which is 2. Because I'm trying to work out the volume of B, I know that I'm going to be timesing by the scale factor for the lengths cubed, because it's volume. So in this case, it's going to be 20 times by 2 cubed. So 20 times by 2 to the power of 3, 20 times by 2 to the power of 3, which in this case is equal to 160 centimeters cubed. Now I'm timesing this time because I'm going from smaller to larger. Okay? If I was going from larger to smaller, I'd be dividing. So there's your answer, 160. Super. So let's just make sure that that's right. 10 and 160, absolutely brilliant. I've got 2 more to have a go at. You might just want to have a go at these yourself. So maybe pause now and have a little go at those yourself. So let's have a go at these together then. So here we've got two cylinders. We've got a smaller cylinder on the left. So here's my smaller cylinder, like so. And this one is A, and this one is B. And it's telling you the volume of each of these. So the volume of A, the volume this time, is equal to 10 centimeters cubed. The volume of B is equal to 270 centimeters cubed. And you're asked to find the surface area, and you were told the surface area of A is equal to 20 centimeters squared. So again, similar to the other ones, we do not know any lengths, so the only thing we can work out, the only two similar things we've got are the similar volumes. So I can work out the scale factor for the volume, which is equal to your larger similar volume divided by your smaller similar volume, which gives you 27. So because it's volume, which is already cubed, to work backwards to find the scale factor for the lengths, I need to do the opposite of that, which is cube root. So to find the scale factor for my lengths, I need to do the cube root of this. And the cube root of 27, you can put in your calculator. So shift cube root, third root of 27 is 3. Brilliant. So I've still not finished. That's only working out the scale factor for the lengths. If I don't have any lengths, I have a surface area that I want to work out. So if I want to work out the larger surface area, I need to times by the scale factor for the lengths area squared. So times by 3 squared in this case. So it's going to be 20 times by the scale factor squared, because it's area. We can take that from the units, can't we? Centimeters squared. So times by 3 squared. Little hint if it is in centimeters. So 20 times by 3 squared, which in this case is equal to 180 centimeters squared for my area, surface area. So have a go at that one on the right. This is the last question. As I said, these are tricky. They come up at the end of the GCSE paper. Usually worth about 4 marks, 3 or 4 marks. Let's have a go at it together then. A on the left is bigger this time. So here, A is bigger. Like so. B over here. And A is there. B is here. So it tells me the volume of A is equal to 13.5 centimeters cubed, and it tells me the volume of B is equal to 4 centimeters cubed. If the surface area of A, so the surface area of this one, is equal to 22.5 centimeters squared, okay, what is the surface area of B, which is small? So first of all, straight away I'm thinking I'm going to be dividing. Don't know any lengths, so the only thing I can work out is the surface area for the volume. Surface area for the volume. What am I talking about? What a plonker. The scale factor for the volume. Be careful with that. Scale factor for the volume. So how many times bigger the volume is. And that's going to be my larger similar volume, 14.5, divided by my smaller similar volume, which is 4. 13.5 divided by 4 is equal to 27 over 8. Notice they're both cube numbers, aren't they? So if I want to work out the scale factor for my lengths, I'm working backwards now. So So the opposite of cubing is going to be the cube root and the cube root. So the cube root, I'll show you how to type it in. So shift there, you see that? Shift that button, the one just above. You'll notice it's just above the X with a little square. 3, fraction button, 27 over 8. You might be able to do this in your head, which is equal to 3 over 2. So my scale factor for the lengths is 3 over 2, which is 1.5. Now remember, I'm not trying to find the scale factor or my lengths. I'm trying to find the surface area. So here, because I'm trying to find the smaller surface area, I'm dividing by my scale factor, which is 3 over 2. But because it's area, it's going to be squared like so. So 22.5 divided by 3 over 2, or 1.5 squared, is 10 centimetres squared. So let's do it down here just so you can see. So 22.5 divided by, because I'm going from large to smaller, 3 over 2 squared is equal to, lovely number, 10 centimetres squared like so. Brilliant. So let's have a go at some of these questions ourselves. Check those, 180 and 10, brilliant. Remember, these are the harder ones, they do come up. So pause now and have a little go at those questions on there. Pause now and have a go at those examples. If you're struggling with those last ones, I'd suggest that you only have a go at the first 2 rows. Super, so I'm going to pop those answers up. So mark those in green for me. Mark those in green. Super, so thank you for watching this video on scale factor and similar shapes of area and volume. Do make sure you're having a go at these questions, because remember, the only way to learn maths is to do it, and have a lovely day.